Welcome back, my dear first 4 subscribers. I've finally come back to torturing my 3D printer a bit more. This video will be part 1 of my current project, an infinity machine. At least that's what it's called in German. I couldn't find out if there's a specific name in English for it. Anyways, the concept of this is quite simple and shown in this little animation running here in Blender. You simply cascade a large number of gears, each reducing the rate of rotation by a given factor. In this case here, I use a 4:1 ratio, so each gear rotates at a quarter the rate of the previous gear. Cascading a large number of gears results in a really slow rotation of the final gear. This animation shows 10 gears, where the first rotates once per second, and so the final gear rotates once about every 3 days. This experiment is often found in science museums, with a larger total reduction so that the final gear would rotate, for example, only every few million years, to make it seem very astonishing. And to further visualize the significance of this, the final gear is then fixed or even cast into concrete. I want to make this experiment for myself, and it will also be a good learning exercise of 3D printing gears. For my final setup, I plan to have 20 gears at a 4:1 ratio, which, if I again rotate the first gear once per second, will result in 8,700 years for the final gear to make a full rotation. Now this is less than the millions of years I mentioned before, but it should still be sufficient to demonstrate the principle, and if not, I can still easily add more gears later on. In this video here, I want to focus on the design process of the gears, and in a second upcoming video, I will then show the final setup once everything has been printed and assembled. Okay, so first off, I started by printing a very large gear with a module of 5. For those of you who don't know, the module of a gear is the ratio of its diameter to the number of teeth, in this case 12 teeth. And it's a common way to define gear sizes because then different gears with the same module will fit together. The shape of this gear with module 5 is very good, the teeth are very clean, but you can guess that with a ratio of 4:1, this would take ages to print because this would be the small gear and the other one would have to be much bigger. So I went down in module, and next I printed 2 gears at a module of 2. And this still worked very well, the shape is still very well defined, and also the gears roll very smoothly. So, because this still worked, I went down even further to a module of 1, which then looks like this. And the shape of the teeth is now not so good anymore, but it still rolls very well. The gear works smoothly, and because in this infinity machine we have relatively low rotation rates and there's not so much force for the first few 100 years that has to be transmitted in my setup, I would say this works very well too. And so I've decided to go for a module of 1 for my setup. Now, with a basic gear size established, it's time to turn to the mounting. And I have some spare 608 bearings lying around, so I decided to print the gears with a shaft that would fit into the bearing, and then on the other side to print a mount that holds the bearing. So this again required a bit of iteration because apparently I'd forgotten the principle of overhangs. So my first bearing holder turned out like this with a lot of overhang at the bottom. So then I decided to print a bit cleaner one, but it still looked a bit ugly. So the final result I ended up with is this. And you can see it in fully assembled form here with the gear and the bearing in place. And while generally it runs smoothly, the specific 608 bearings I had left over were not very light, not very easygoing bearings, but rather designed for example, skateboard use, so capable of taking a bit of weight. And so there still is a bit of friction, although not too bad. And also I noticed that some of these bearings are quite wobbly, which rather is going to be a problem because the gears might move out of each other. Okay, so instead of one possibility, which would be to order new and better bearings. I decided that because this doesn't involve large forces, I could try and basically print my own bearings, or rather print it as a bearingless approach. So this is the next step that I did, where again I had a gear wheel just with a long shaft attached, and now the holder is just a hole which this gear smoothly fits into. And I made a bit of a special process out of it, where I printed basically the shaft and the hole too tight so they wouldn't quite fit, and then ground them to fit each other using an abrasive paste. And I will show you the process in detail in a little while. Of course, again, a bit of iteration went into this design. So first I had a single straight shaft like shown here, and a single straight hole going all the way through with the same diameter by design. But my grinding apparently, so by applying a bit of bending force in this direction, or whatever the reason was exactly, the shaft and the hole didn't turn out very straight. So while small, there is still a bit of wobble in the gear going on. Probably the mount I have here wouldn't be detrimental for the final setup, but nevertheless I decided I can do better than this and iterated the design. This animation shows the design I then went with. The shaft and hole are segmented into 3 sections with 8, 7 and 6 mm diameters, indicated by the red, yellow and green colors. Additionally, there are wider sections of the hole to reduce the surface area that is in contact, and so also the surface area that I need to grind to shape. This reduces the amount of grinding required, and with 3 sections there is some redundancy, as you only need 2 to have good guiding. Again, no idea if this is strictly necessary or actually helpful, but it works for now. And on to the post-processing of the 3D printed parts, for which I got myself set up next to my sink so I had access to running water for cleaning. I also prepared myself some tools, including 2 small files, a flat and a round one, a small piece of fine sandpaper, and finally a silicon carbide lapping paste, which is normally used for honing knives on leather. I started off with a flat file to remove any sort of strings or zits, as well as the seam on the round shaft of the gear. I then used the small file to clear out the inside of the hole in the mount. Next, using the sandpaper, I further smoothed over the shaft. And don't forget to rinse occasionally to remove any debris. After drying the parts, I turned to the lapping paste by applying a small amount of it onto the shaft of the gear. Once the paste was applied, I inserted the shaft into the mount and slowly started grinding. An important aspect to also consider is that there's a lot of friction, and so the plastic will get quite warm. For PLA with a low glass temperature of 55 degrees, that means you can get deformation of the shaft. It took a few iterations of rinse and repeat to complete the whole process, and on my first attempt I needed about 10 minutes. And just for a quick demonstration, here are the first 2 gears I produced in action, bolted onto a little aluminium rail. And if I turn the first gear, which would be basically the input gear, you can see that the second gear moves slower, and with 2 gears it also works that I turn the output gear and the first one moves faster. Thank you again for watching my video. I hope it is helpful for you if you are involved in any project that requires you to 3D print your own gears. Stay tuned also for the second part of this video, where I will show you the final result once I've printed and assembled the whole experiment.